Hi there. We are going to play around with exceptions a little bit in this video. So exceptions are used to help handle errors and unexpected outcomes in a computer program. So let's start by taking this very simple piece of code here, which starts by creating a scanner object, looking at the keyboard, creates a variable, an int called x, which is equal to 10, and then prints out a statement to the console. Please enter an integer, and then sets another variable y equal to the next int typed in that the scanner looks for, and then prints out the result x divided by y, and finally prints out a message that has successfully completed the program. Now, again, very simple program, so let's just run it and be sure that it works the way that we expect. So it says enter an integer. I'm going to type 5 to the console and hit enter, and it prints 2. So 10 divided by 5 is 2, and then print successfully completed the program. Now, this line here makes a fundamental assumption about the things coming into it. So I have int x and int y, and the compiler knows that ints can be used to do division. If I were to, say, put a string y equals cat and comment out this line, I would then get an error because it would say, well, hey, you can't take an int and divide it by a string. That doesn't make any sense. But it is okay to have an int divided by another int. So I get no errors right now. But as a person who understands mathematics, we should know that you cannot divide by 0. So what would happen in the case that the integer entered is a 0? Well, let's find out. So we're going to run the program again. It says enter an integer. I type in 0, and we see exception in thread main, java.lang.arithmetic exception divide by 0 at testproject.testproject.main, and then testproject.java colon 29. So it's saying it's happening on line 29, and Java result 1. So this is an error message that if you are uh, anywhere past your first time running a Java program or any program, you have seen, we see error messages all the time. These are exceptions. They tend to be really annoying, though, because they usually crash our program. So we as programmers can actually plan for it and anticipate when an exception might come up and handle it in a way that prevents our program from crashing. So what I'm going to do is change this around a little bit, and instead of leaving this line by itself, right above it, I'm going to add the reserved word try, and I'm going to put this statement, this divide statement, in a little code block. So I'm not saying to do this line, I'm saying to try to do this line. So it's a little bit different. But you'll notice I'm getting an error message here. It says try without catch, finally, or resource declarations. So what that means is if I tell the computer to try something, I'm telling it that there may be a problem in the code below. There may be some exceptional case, such as somebody trying to divide by 0. And I don't want the computer to panic. I want it to know that I'm going to handle that. But handling it requires something like a catch or a finally statement. So I'm going to go right after the code block and put another reserve word in, catch. And a catch takes parameters. And we're going to say catch an exception, P, and then give it its own little code block. And I might just say print out, print line, P. Oops, that's a 2. P. So I'm saying try to do this line of code, but if an exception gets thrown, catch it right here, and then just print the contents of that exception, whatever that exception may be. So let's try running this again. You notice there's no errors right now. And first, let's do our simple test. So I'll put in 5 and make sure it works the way that we intended originally, and it does. And let's try running it again, but this time I'm going to put in 0. And I still get this exception message, but I still successfully completed the program. I still got to this line on 31. So having this try and catch in there allows me to, as a programmer, decide how to handle the exceptional case that the computer was not expecting. Now, this is not necessarily the best way to write code. This is a very simple example intentionally to point out what exceptions are and how they can work. It might be better to do something such as, say, while y equals 0, print out a statement that says system.out. Print line, you can't divide by 0, enter another value. And then just take this line again and put it right here. So in this case, I'm preventing myself from ever getting into that exceptional case. But we can't always do that. We don't always know what those exceptions might be, especially in terms of when maybe there's a null pointer exception that we have somewhere in our program, or if we're taking user input in and we're not quite sure exactly what they're going to put in or how it might break our program if they put in, say, a file name that doesn't exist or a value that we weren't expecting, or try to select an element in a range it's not there. But this method of using exceptions is very helpful for preventing programs from crashing because of a smaller problem in the context of a bigger program. So let's do one more example, and I will get rid of most of this. So instead of having x be a single value, let's make it an array. And let's put in a few values. So how about 3, 5, 7, 9, 11, 13, and 27? Why not? And so now I have an array, and I'm going to take in an integer. And this time, instead of dividing by 0, I'm going to say, go to the yth element of x and print out that result. So if I run this and I put in a 0 now for y, it should give me a 3 because 3 is at the 0th element. And it does. Lovely. But I have a couple problems. What if I were to type in a -1? What if I were to type in something longer? So I could handle that out of bounds exception with this try catch statement. So to run it again, and let me put in the 23rd place. And there is no value there. So array index out of bounds, 23, still successfully completed the program. Now, what I could also do with these exceptions is, instead of printing the exception, I can figure out, what do I want to do in the case that a person does not use the program right. So, for example, if I said, hey, select one of these values, and the person using the program entered -1 or entered a number that was too big, I might say default value chosen. Instead of printing this out, we might say I have int value, and I would say, hey, I'm going to try to let the person pick their value, but in the event that they don't, I'll say value equals x position 0. I have 2 lines now in this catch statement, so I'll expand this block a little bit so it's a little easier to read. So we would say, hey, if this person tries to pick a value that's not there, just assign the value 0, and we'll say successfully completed the program. Value chosen was value. All right. So we'll run it again, and let's first try to have it work properly without getting the exceptional case. So I'm going to say go to the 4th position and 0, 1, 2, 3, 4. So I should expect an 11. And the value chosen was 11. Looks like it works. Now let's try it again. And if I type in -1, I don't see that error message. It just says default value chosen. Successfully completed the program. The value chosen was 3. So in this case, I was able to say, hey, if this exceptional case happens, here's how to handle it. So again, this is another very simple example, which a try catch might not be that appropriate. An if statement or some kind of while loop might be more appropriate. But for the purpose of illuminating what exceptions are and how they work, hopefully this made some sense to you. That's all now. Bye-bye.